injection molding. In this process, the plastic material is melted in the injection chamber and then injected into the mold where it cools, and finally the finished plastic part is ejected. Okay, this one is a injection molding mission. Okay, here Whooper you can take the plastic granules and fed into the injection molding mission. It is then here heating coils are used here. Here these are melted and this one fed into the mold cavity. Okay, now we will see the working principle. Okay, this one is the working principle of the injection molding mission. Here the mold cavity, and this one is the injection section, and this one is called the clamping section. Okay, first we done the clamping. After that, in the Whooper we take the plastic granules, and these are the heaters. These plastic granules are heated and melted here, and this one is fed to the reciprocating system to the molding cavity. When the part is cooled, then it is ejected. Okay, now we will see the stages of the injection molding. Okay, the complete injection molding or process is divided into 4 stages. First one is the clamping, and second one is the injection and cooling, and fourth one is ejection. First one is clamping. In this, the two halves of the mold must be tightly closed. The molten plastic material is injected into the mold. Once the half of the mold is attached to the injection unit, then other half is allowed to slide on the guideways. The clamping of the mold is operated hydraulically, which is pushes the mold moving off of the part of the mold towards the fixed part to make an airtight chamber. The force and the time required to close and open the mold depends upon the mission capability. Here, the second process is injection. In this process, because of that heat, the material is melted, melted and forwarded through the piston towards the nozzle and finally into the mold. Then the molten plastic is injected into the mold cavity quickly. We will see the short volume. What is short volume means? The amount of material is injected into the mold is referred to the short volume. It can be estimated by the injection power and pressure, and the injection time is estimated due to from the short volume and injection power and pressure. Now third one is the cooling. Okay, after injection it begins to cool. As soon as it comes to contact with the mold surfaces, the mold part cools, it will solidify into the desired shape of the product. Next, final stage is ejection process. Here the rear half of the mold has to be ejected from the mold. When the mold is opened, the ejector mechanism is used to push the part out of the mold. Force must be applied to eject the plastic part because during cooling the molded part sinks and adheres into the mold surface. This process, it will take 2 to 60 seconds. After that the process is repeated. That means the 4 stages are repeated. Okay, these are the materials used for the injection molding process. Injection molding process. Okay, we'll see the applications of the injection molding process. Generally, these are used for walled plastic housing products and household appliances, electronics, and open containers like buckets and toothbrushes and small plastic toys, medical devices, including valves, everything for this you can use for the injection molding process. Then what are the advantages? We will see the advantage. The production rate is high, and we will see the close tolerances on the small intricate parts, and the minimum wastage of the raw material, and complex geometry can be easily produced. And the disadvantage is the initial tool cost is high, and the setup cost is also high. Large undercuts cannot be formed. Next one, the important process parameters. The important process parameters are injection temperature, pressure, and shot volume, and mold temperature, and cooling time, ejection temperature, and the cycle time. We'll see the common defects identified from the injection molding are flash, blister, warping and bubbles, unfilled sections, jetting, sink and ejector marks. Okay, thank you.